Okay, I see it's recording. Okay, nice. So, so when Alish, the Professor Martinez asked me, seeing whether I can do a lecture in front of you guys, I was thinking like, what topic should I do? What do you guys learn? You guys learn a bunch of things related to how the brain works, which is very useful. You guys also learned the low-level features like sift, surf, all of those kind of things. Maybe a bit recap of linear least squares, I don't know. So today will be quite independent from what Professor Martinez have taught. We'll talk about something more implementational. So you guys don't have to make any notes, just lay back, chill, right? And everything will be online. And this slide probably contains most of the information you'll be looking for. So you don't have to write down. And it will be easier, you can focus on the things that I'm talking about other than writing things down. But, it's your freedom. So it's a free world. You can do whatever you want. Yeah?
Can this lecture be recorded and uploaded?
Yes, it will be recorded. Yeah. So, so we'll talk about implementation practices in computer vision for individual researchers. So it is not like a huge group of researchers, the practice of that, because I had zero experience of this. So primarily, I usually just do individual research. The project, I only write code for myself. I don't collaborate extensively in terms of code with other people. So that will be probably the case that you guys will meet in this class, hopefully. When you're doing homework, you're writing your own code instead of sharing with some of your nice friend and doing a GitHub collaboration. Or use some, just copy some pull some open source script. Hopefully that doesn't happen, right? So here today we'll talk about 4 things, actually. This is implementation and practices. It's not just about the code, but primarily a little bit more of, yes, it is a bit about code, but also how do you stay updated, following the state of the art in the computer vision field. So we'll talk about 4 topics. 4 topics first will be about the off-the-shelf implementation of computer vision algorithms. Right? Off-the-shelf are the ones that, we learn about SIF, we learn about SURF, PCA, all of those kind of things. You might not want to implement yourself, right? First, you might get it wrong. Second, it might not be as efficient as the other people's work. But if you want to do it, you can do it as a learning experience. So, and then we'll talk about off-the-shelf implementation of optimization methods, which some of you might be familiar with, some of you might not. We'll get into detail, a little bit detail into that. And then we'll talk about code management and version control when you do coding in computer vision projects or any projects related to coding. At the end, we'll say what are the resources to follow up the state of the art in computer vision. All right? And so let's get into the first one. So first is very standard things, what are the primary sources for off-the-shelf implementation are MATLAB Toolbox and OpenCV. Actually, MATLAB Toolbox, when 100 years ago, a couple years ago, it wasn't really there. The image processing and computer vision toolbox is actually partially developed based on the OpenCV. And there was a binding algorithm between OpenCV and MATLAB. So MATLAB's thing is based on that, so it has a lot of overlap functionality with OpenCV. But since MathWork team has since actively developing this toolbox, now it has a lot more functionality. And sometimes it's not exactly overlap with OpenCV. So in MATLAB, usually you just go with the first 2, image processing toolbox, computer vision toolbox. But VLFit, which is another open source MATLAB toolbox, which particularly nice when you're working with SIFT or SURF. If you have a homework, I don't know whether I can say that, but if you have a homework for Civ Serve, that will be a recommended one to use. And then about OpenCV. OpenCV source, the source code is in C++, but you can definitely do Python binding in OpenCV, which make it much more friendlier. And we'll talk about the downside of OpenCV. So all of those, so those little links are the resources. If you go to the slides, you can check it out. It contains the documentation for each of them. So MATLAB, what is good about MATLAB? How, like, I'm assuming everybody is using MATLAB. And MATLAB is really good for fast prototyping. By, like, what do I mean by fast prototyping? I have an idea, right? I want to implement this, right? I also want to combine this, but I don't really care about performance. I just want to put it there and see how well it works in terms of other, like, the metric, not related to the speed of the algorithm. So, for example, how does the what would be the image look like after I applied this filter, that filter? What would be the Civ key point located? What would be the Civ features? All of those kind of things. And MATLAB is really good at this for the following reasons. First is very close to mathematical formulation. By that I mean the way you write the code is just like the way you write equations. And it has particularly close relationship with matrix operation. When you go into Python or other things, you have to use cumbersome functions, for example, to do even dot product between matrix and vector. So, but MATLAB, just a star will work. Second is whenever you have things that you don't know whether there is a function, you can just go to the MATLAB documentation and find it. And documentation is super clear and it's very consistent across different toolbox. So by that, it has a very clear structure. So you know, what do I need to do? What do I need to put into the import argument? What do I expect from this function? That's very clear. This is coming from a benefit of a closed source. There's a dedicated people working on documentation in MathWorks. And then you can access, once you install MATLAB, especially in Ohio State, you are granted the vast access to almost all the toolbox that MathWorks can provide it, which include a lot of toolboxes you might find very useful for your project. Not necessarily exactly the computer vision or like image processing toolbox, but like optimization toolbox, statistic and learning toolbox, parallel computing toolbox. All of those will be particularly useful. And for MATLAB, you don't have to sweat how do you install them. When you use it, they're already there. You just use it, right? You don't have to install those kind of things. And last but not least, MATLAB has a very good, very intuitive debugger. When you develop a MATLAB algorithm, a program, it's very easy to debug. Every step you can see what the variables values are, and you can see where it is, and you can just hand over your mouse to the variable, you can see what's going on. So it is a very friendly debugging environment, which is you rarely see in any other programming language. So all of those points combined make it a fantastic tool for fast prototyping, right? If you don't care about performance, I don't care about running it in real time, right? I don't care about putting it into phones, and I just want to see in algorithm level how things works, right? MATLAB probably is the best thing you can do if it can provide the function that you're looking for. But it still has a lot of problems. First, it's not free. That's the biggest problem. It's quite expensive to get one of those things. And second, it's generally slow, unless you optimize it using matrix operation. But not every program can do it, and not everybody knows how to do it. And it's sometimes it can be quite complicated. And then the other is, even if you have a huge amount of toolbox, the function is still quite limited in terms of what you can achieve. So then let's go with OpenCV in Python binding or C++. So obviously, first, it's fast. It's very fast. A lot of real-time computer vision algorithm using OpenCV. And second is very close to machine. Like when you do Python and C++, you can use a lot of system. It's very close to system level and machine level. So you can use a lot of tools that is not available in MATLAB, but is available in Python and C, which is usually quite low level and close to the OS. And third one is you have a huge access. You have an access to almost unlimited libraries in Python, especially in Python. So including those popular deep learning libraries, TensorFlow, PyTorch, all of those kind of things, if you want to use it for solving computer vision problems. And of course, it's free. And then after you, because it's the nature of those C program, it can be put in a portable application. It can be scaled very easily. But the downside of the OpenCV is the quality of the documentation really varies. And those are common problem in open source things. You go to this library, it has fantastic documentation. You go to another one, it has really poor. You don't really know how to use it. So you don't really have that consistency in this kind of environment. And then the problem is you have to manage dependencies. Anybody sitting here, I don't know, have installed OpenCV on your computer. It's a pain in the butt, but I mean, it is very powerful too, but it is very painful to install those things. The infamous, this one, and Caffe, which is another old deep learning library, was an infamous couple of things that's extremely hard to install, and they are actually depending on each other. So it's very hard to manage the dependencies, especially when you're working with C. So now, you know, in Python, it's a bit easier. You have, conda, pip, all of those things will help you, but it's not like as easy as in the MATLAB. You just say, just use this, just use that. You don't have to worry saying, import this, import that, worry about the version of each module. All right, so that's pretty much the pros and cons. So at the end, how do you select? For this class, let us use MATLAB. All right, unless we are doing a deep learning based project, then we probably don't have other choice than to use Python. Because we don't really care that much about the nitty-gritty details and subtleties in the program implementation that is particularly helpful in OpenCV. What we more care about is how the algorithm is designed, how the theories work. That's pretty much the goal when you're doing program-based homework in this class. All right? But for some people that kind of familiar with one but not the others, try to do something in the other one. Then you can appreciate the other a bit more, right? So, and second, let's go with the off-the-shelf implementation of optimization. So in the class, professor usually say, we just solve it using what? Linear least square, non-linear least squares. But exactly how, right? So given the objective function, finding the parameters to optimize this objective, which in the linear least square and non-linear least square sense, is usually the square laws, is the mathematical problem called optimization. It is a well-established field. There's a lot of algorithm for it, and there are off-the-shelf implementation for that. So once you have a linear, non-linear least square problem, you can put it into one of those off-the-shelf implementation, and it generally will give you a pretty decent result. So we have dedicated in ECD. Have any of you take optimization class already? You take? Yeah? Nice. Good. All right. So we have a dedicated optimization class in the department. 5759 nonlinear programming, solving the problem for nonlinear problems, and 7100, which is, they call it network optimization, but it's more like a convex optimization applied in the network setup. And both are very useful for understanding the optimization. So for the people, and so highly recommend, if you want to do some computer vision thing, learning computer vision is obviously very important, but also how do you solve, once you formulate a problem, once you formulate a computer vision problem, then you want to solve it. Then the way to solve it is using optimization technique. So it is also, is also one of the pillars to support your work of computer vision. So I'm just going to talk about possible functions you can use. If you don't really know what I'm talking about, that's fine. You just, the slides are there. And if you, once you learn more about it, you can just refer back to this and find out, it maybe make more sense. So fmin_con, so function minimum constraint, is to optimize against a constraint problem. The constraint problem is you have the objective, but you also have a specific space of parameters you're looking for, right? It's not the entire space. And then you have function minimum unconstrained, which is dedicated for unconstrained problem. In MATLAB, there's both of them has quite a few options for what optimization method you can use. The first one, I think the default is interior point method, and then the other is simplex, and then you can switch to simplex method. And for the unconstrained, the default is trust of region method, and then you can switch to quasi-Newton method. So but this f is not very structured. You can pretty much give any f that it can solve. So when the function, the objective is much more structured, for example, it has a linear structure or a quadratic structure, and a quadratic thing that professor written on the whiteboard X transpose QX, those kind of form, has a specific structure. And in those cases, of course, you can derive closed form solution, but also if you want to use off-the-shelf programming, you can. Limprog is for linear programming, and quadprog is for the quadratic programming. So those are the MATLAB optimization toolbox. But if you want to use gradient-based method, which is very typical way of doing optimization, what people usually do, you just calculate the gradient and implement yourself in MATLAB. That's one way. But there is another way coming from the automatic differentiation capability provided in most of deep learning packages. So in TensorFlow, in PyTorch, all of them have automatic differentiation. Because the network architecture can be really complicated. You don't want to calculate gradient with respect to all the parameters by yourself. So they have automatic differentiation, which means that you don't exactly have to calculate the gradient by hand. The machine will keep a record of whatever operation that you did, and it will apply the chain rule automatically. And it will save a symbolic representation of how each of the gradient is calculated. So this will be the thing, if you if you met some of the problem in the homework, right, you have the objective written down, right, this has to be minimized, and then you don't know how to solve, go back to one of this, see which one can fit it to your objective, and just let it run, right, and probably you'll get a decent enough result for the problem in the scale of this class. Okay, so we finished the off-the-shelf implementation for computer vision and optimization. Let's talk about a little bit about code management and version control. Why do I talk about this? Because I don't know how much you do on programming in one project. But let's say you're doing a programming, you're doing your coding nice, doing your work, 2 months, 3 months into the project, you have a huge amount of code. And you have, let's say if you do handwritten digit recognition on MNIST, right? And then you have MNIST using this network, And let's say using that network or version 1, 2, 3, 4, 5, 6, and 1A, 1B, 1C, right? And one day you're sitting in front of your desk and looking at the code, which is MNIST version, let's say 9Z. You're thinking about what would be the next name for your next implementation. And your boss commented. You say, you know what? I think the version that you developed like a month and a half ago, that one was pretty good. Let's just use that and develop based on that. And then say, yeah, okay, yeah. And then you go back to all of your code and look at all of those versions, and you don't know what's going on, even if they're all written by you. You don't know which one corresponding to the one that have a specific method. You have to go through all of them. It's a disaster of versions. So this is particularly the case for the project that contains a lot of modules that are interact with each other, and also requires a lot of tweaking in the code. Right? For example, the deep learning-based algorithm, you have to tweak this parameter, tweak that parameter. You have 1,000 knobs you can turn. Every time you turn a little bit, it's a new version. And in this case, the code version can really go out of control. And version control in research or in many of the other places is very important, because the latest version of your code might not perform as good as your previous version. The performance might deteriorate depending on what kind of methods in your latest version. So you do want to keep a record of what you do, right? And so in conclusion, the managing code is very useful for reducing the number of versions there, the standalone version in your project space. And it will keep a clear record on the changes that you made on each code, on each version. And then you can annotate each version saying, this version, I make this change, and I got this result. Right? Then it will really easy to go through and check what would be the correct version to use, and you want to roll back to. All right, so talk about all of those benefits. How do we do this? Probably everybody already know. We use Git and GitHub. Well, you don't have to use GitHub. Probably Git is a must, but GitHub doesn't really necessary. You can use whatever remote repository service that you want. But here I am presenting you guys with GitHub. But GitHub has a lot of functionality, and Git have a lot of functionality for between inter-person collaboration. But here, since we're only focusing on individual researchers, I'm not going to talk about like Git merge, all of those disasters. So I'm just going to talk about how do you push your new version to Git and annotate it using Git and GitHub. So I create a little demo that is a typical scenario for your code. So GitHub demo, which contains a bunch of Python code. Each of them is a different version. It's all start with action, again, whatever. And it has a test mat. It has the data. And it has some MATLAB code too. It's all mishmashed. And first step, try to organize your project space so that data is data, code is code, result is result. Because you don't want to upload data to GitHub. GitHub don't like big things. Like GitHub like small script, rather than you like submit a 200 gigabyte data into it. It's going to complain a lot. So you just put a nice hierarchical data, code, result, and we'll upload the code to GitHub. So once you've done this, don't forget to change the dependencies in the script once you change the directory, right? Otherwise, the code is not going to run. And then go to your GitHub page, start a new repository. If you haven't got one, apply one. I'm not going to make an advertisement for GitHub, but it is free. And even a free version, you can create a private repository, which is pretty nice. So in this, at the top right corner, there is a little plus. Click it, and you can select create a new repository. So when you create a new repository, it will ask the name, put a name that you want, primarily pretty much just associated to the name in your workspace. And they'll ask, do you want to initialize with readme, git whatever else? And say, no, you don't want. You just want a very empty repository in the GitHub right now because you're going to push a bunch of things into that. If you put a little bit thing, it's going to complain, saying version doesn't match, git merge, use git merge, all of those kind of things. It create a lot of conflict. So initialize with nothing, just a folder, just a name, right? And then you go to your directory. Go to your directory where your project is saved, the data code result things that we just created. First run git init. Initialize the repository in your local directory. And second, git add code. You can see, this is probably too small, but here it is. So this will add everything in code to your first commit. And then here, comment this commit by, OK, that's probably too low. Here you get that there too. You can just comment it, git commit -m and your comment. Whatever comment you want to put there, I will recommend something related to the current change in your repository. Am I using this architecture? Am I using that architecture? Right, this comment will be something you will see later on. Will show you like as a label of each version. But you still can add additional annotation to each version after this. So after this, almost done. And so now what you want to do is you want to push it to GitHub. GitHub, which is a remote repository. So if you go back to the website where you just create your new repository, this page will show up. A quick setup. And you click this, you will copy the URL that you need, and go back to the terminal and say git remote add origin. And remote repository URL will be whatever you copy from here. And so once that's set up, git remote dash we will just check whether the server is correctly set up. And it will show you, fetch is this, whatever is that. And you check, OK, that's all fine, all correctly set it up. Final step, git push, right? Git push origin. And it will prompt like what will be your username, what will be your password. And after that, you can push your new version, the first version to your GitHub. That's what it will show up. This will be the one, the project, and this will be your first commit with this labeled as your current version. The first try, don't know whether it works, it's obviously worked. And so go to the repository, check whether it is uploaded correctly. And so that will be the first commit. If you change the code, what do? You repeat step 3, 4, and 6, right? You don't have to put the remote URL again to let the GitHub to let the Git know which remote repository you're referring to. Once that is set up, is once for all. So 3, 4, and 6 will be the one that you need to use. So git add, git commit, and git push. Right? Those are the three. If you only care about version control, those three are what you need. All right. So hold on. So 40 minutes. Okay. Yeah. If we finish early, you guys can leave early. OK, last is when we do computer vision research, we do want to follow the state of the art in computer vision field. In almost any research, you want to follow the state of the art. Particularly in computer vision, it's because it's developing so fast. And if you, like a couple of months, you don't read the literature, it's kind of, you feel yourself is already obsolete. So like following the latest study has a couple benefits. Right, like it is not saying like if you don't really care, you don't have to do it. But what are the benefits? Why do I have to follow the latest study? First, you can see whether there's a new method for an old problem, for an existing problem. Is there a new method for object recognition? Is there a new method for local low-level feature extraction out of those kind of things? And second, is there a new problem emerged from the field, right? Is there like kind of those, adversarial attack, counterattack, generative model, like all of those Bayesian inference, all of those kind of things? Maybe there are some specific topic emerged from the field that you might be interested in. And third is it's old method and old problem, but people are talking about a new understanding of them, which might also be beneficial for you to theoretically have a deeper understanding of the previous method. And at the end, last but not least, is maybe some famous guys call for a new standard of running an experiment. When they'll say like, the previous fixed set validation is not good enough. You have to run cross validation. You have to run this. You have to run that. Make sure your results reproducible out of this. Like keep an eye of those new standard, and then you can apply it to your own research to make your study more reproducible, more stable. All right. So talking about the benefit of this, how do we actually keep up to date? So most obviously read papers. So reading papers that published in top journals, top conferences. There are so many journals and conferences, you're probably not able to cover all of them. But we'll give you a list of top journal and top conferences, which you can keep an eye on once in a while, and you can see what's going on in the field. And second is you go and attending those conferences. Talk to because in the conference are all of your colleagues, and all those people are doing things in the field. You can talk to them, see what's going on, how are you doing, right? What is your current research? Just talk about all of those kind of things. So you will have a direct impression of what all the people are doing in the field. And the third one will be a more casual one. You just go to the seminars, workshop locally, if you can find one, and talk to the people who work in the field, right? And just hang out with them and see what's going on. Those are more casual things. But primarily we'll be reading papers from those top conferences and journals. So how do we pick conferences and journals? If you have a relatively general interest of things, first two is quite obvious. So the multidisciplinary journals, which are the ones that cover almost all the topics, but they only pick the one that's very influential. In the Nature and Science and Proceedings of National Academy of Science of the United States is the three most impactful multidisciplinary journals you can find. And you can just go the articles, each of those, each of those little URL will guide you to the article page of of each of those journals, and you can take a look. There are probably not a lot of computer vision research. There may be some of the machine learning, but if there is one, it's usually a very important one. And those are multidisciplinary journals. But for a more specific computer vision journal, there will be the best one will be the Pattern Analysis and Machine Intelligence. So that's an IEEE transaction, or short for PAMI or TPAMI. And International Journal of Computer Vision, IJCV, is also a very important one if you want to follow in computer vision. So CVIU, computer vision and image understanding, is a bit it's still respectful but not as good as the first two. So those are the journals. But journals nowadays, a lot of scholars don't like to publish in journals because the review process is very long. Generally, you take a good amount of months to get a first round of review, and you do the revision, you do the rebuttal, and then you go to the second round of review, go to the third round of review, and when it published, 2 years later. And then people think, if it's 2 years later, it's already too old. And so although it's nice to be publishing things in all of those fantastic journals, but Like if it's too old, what's the point? So people, let's see. So people are nowadays more prefer conferences. So the conference is also a nice thing about conferences. Most of those conferences has open access. You don't have to subscribe to IEEE whatever, and you can get access to all the papers published in conference. So the best 3 conferences in computer vision, Computer Vision and Pattern Recognition, CVPR, International Conference on Computer Vision, ICCV, and European Conference on Computer Vision, ECCV. Those 3 are probably must follow if you want to work in this field. And typical way is whenever a new conference is come out, right, the open access come out, and you just go there and check all the papers, right? You just, you categorize them into different topics and give a quick read on the title and abstract and see whether there is anything that you're interested in. So computer vision, CVPR is held every year. The other 2, ICCV and ECCV, held every another year. So once every 2 years. And those 2 will iterate, right? This year will be ICCV, the other year will be ECCV. And there are some other journals and other conferences also kind of important. Nature Machine Intelligence is a kind of like a new journal. It was issued I think it's early this year. Pretty theoretical, but it talks about very general issues in machine intelligence. Transactional image processing is primarily, from the name, it's just about image processing. Affective computing, more about recognizing emotion, affect state of those. Not necessarily computer vision, because it can use many other sensors too. So Journal of Machine Learning Research, JMLR, also, so it's related, but not like exactly computer vision because it's about machine learning. So image and vision computer is another journal. Actually didn't heard much from that. So some other conferences still respectful, but you don't have to follow. In my point of view, if you have to choose, pick the one in the top 3, right? And ACCV, Asian Conference Computer Vision, British Machine Vision Conference, those are also pretty respectful. WACV, which is more about application. If you find something about application, you can go WACV. Face and gesture recognition, which is primarily just focusing on face and gestures and nothing else. So other than that, there are conferences that is not about computer vision, but will cover, the paper will apply their method to computer vision application. So NeuroIPS, the conference on Neural Information Processing System, which is primarily a machine learning conference, but huge amount of paper is applying their machine learning algorithm onto computer vision problems. And then ICML, similar conference, very machine learning oriented, but at the end, you can see how those algorithms apply to computer vision problems. And VSS, Vision Science Society, that's a kind of like a special one, but this is more neuroscience. Neuroscience, cognitive science, psychology, which is you get the idea of how human vision system works and the latest result of that. And at the end, AAAI conference, which is a very, very general, very broad conference. It covers natural language processing, a little bit computer vision, a little bit this, a little bit that. You can follow if you want. It will be nice if you more focusing on interdisciplinary intelligence application. All right, I think that's everything for today in computer vision. So any question, comments? No? All right, good. You guys are good to leave if you want.